Hey folks, today we're going to be working on section R5 and R8. So these are going to be from the review chapter, and we are going to be working on absolute value equations and inequalities. This is going to help us with our calculus prep for when you guys get to Calc 1. So if we're going to start with, say, the equation, the absolute value of x is equal to 3, if we want to solve for what x is, think about what absolute value means. Absolute value is measuring the distance from 0. So if I'm looking at a number line, well, what numbers are 3 units away from 0? There's two numbers. Positive 3 is 3 units away from 0, as is negative 3. It is also 3 units away. Remember, a distance needs to be a positive value. So for this particular equation, we would say the absolute value of x equal to 3. Our solution set would be negative 3 and positive 3. Now let's add a little bit more excitement to this equation. If we have the absolute value of x plus 1 is equal to 3, well, what's inside of these absolute value bars could be positive 3, because 3 is 3 units away. What's inside of there could also be equal to negative 3, because when you take the absolute value of negative 3, you're measuring that distance from 0, so that would still yield a positive 3 for an answer. So we are going to take what's inside those absolute value bars and set it equal to a negative 3. Now, these turn into two different equations, but they're both really nice to solve. So for the first one, let's go ahead and take away 1. So that gives us 2. And then the other one, let's go ahead and take away 1 as well, and that's going to yield negative 4. So you could do a quick check. You could plug 2 back in. So is the absolute value of 2 plus 1 equal to 3? Well, absolutely, because that's the absolute value of 3, which is equal to 3. So that side would check out. And then likewise on the other side, is negative 4 plus 1 the absolute value of that? Is that equal to 3? Well, that yields the absolute value of negative 3, and that certainly is equal to 3. So both of those solutions would check out. So I'm just going to write them in order from smallest to largest. Now, it could get a little bit more complicated inside of here, but the idea is still the same. Whatever is inside these absolute value bars could be equal to whatever we're setting it equal to. So in this case, it would be equal to 10. The second case that we could have, whatever's inside those absolute value bars, that could equal negative 10. Because again, when you take the absolute value, that's going to yield a positive answer for our equation. So let's look at the first equation. I'd start by taking away 2 from both sides. And then I could divide both sides by negative 4. So x equals negative 2 is going to be one of our solutions. Working on the other equation, I'm still going to do the same steps. I'm going to take away 2 to start with. And then I'm going to divide by that negative 4. But since I had a negative 10 on the right-hand side, in the end, this is going to yield a positive 3. So here's my 2 solutions. Again, with any of these absolute value equations, you can really quickly go back in and check to make sure your solution works. If I plug in negative 2, this would give me 2 times negative 4 times negative 2, the absolute value of that. And is that equal to 10? Well, let's see what we get. Negative 4 times negative 2 gives me a positive 8. 2 plus 8 is 10, and the absolute value of 10 is most definitely 10. So that side checks out. And then if I plug in 3, 2 times 4 times 3, the absolute value of that, is that equal to 10? Well, this gives me 2 minus 12 inside the absolute value. So if I'm left with negative 10 inside that absolute value, negative 10 is in fact 10 units away from 0. So that one checks out as well. Things can get a little bit crazier. So now this one we have 5 times the absolute value of 2 minus 4x equals 50. So this one is very similar to our last one, except now we have this multiplier out front. So I need to get rid of that first, so that way I can just isolate what I am taking the absolute value of. So now notice with that one step, this turns into exactly what we saw on the last problem. So refer back to that last slide, and we're going to end up with negative 2 and positive 3 for our solution. Now, something like this is very, very similar again. I'm going to start by dividing both sides by 5. And this is going to equal a negative 10 on the right-hand side. So notice this isn't exactly the same as the last one. It's very close, but not quite. So this one, I actually know the answer to it right away. I don't have to do any other work from here. I know this has to have no solution. because I'm taking the absolute value of something, so whatever this is inside of here has to always be 0 or a positive number. So it will never ever equal a negative number. So once I notice that, I'm done. This is no solution. Now, sometimes folks miss that and they go through and they try to solve it. So they take the first case just as is, and then the second case, they're taking the opposite and ending up with that positive 10 here. So I'm going to do some quick solving. Let's see, let's take away 2 from both sides and divide by 4, so that gives me 3. And we'll take away 2 on this one and divide by that negative 4. So you're like, hey, I can still come up with these 2 answers right here. Well, look at what happens when you plug them back in. So just for fun, we'll plug 3 back into the original problem. If I do 5 times the absolute value of 2 minus 4 times 3, and if I set that equal to 50, let's see what we get. Inside the absolute value, that would be 2 minus 12. So that's going to be a negative 10. So I'm going to have 5 times the absolute value of negative 10. So I'll continue my work over here. So absolute value of negative 10 is positive 10. So will that ever equal negative 50? No, because that's going to be positive 50 equal to negative 50, which is not a true statement. So even if you kind of missed that it was set equal to a negative number, then you would still get your 2 answers, but when you plugged them back in, neither one would work. So this one would be just the empty set, because there is no value that would make both sides a true statement. Now, don't think just automatically because you see a negative 50 over here that this one has a no solution, because notice here you have a multiplier of negative 5. So if we actually divide both sides by negative 5, we end up with that original problem here, where we know what the solution is going to be here. This was negative 2 and positive 3. So just be careful there. You do need to get it all the way simplified so that the absolute value is totally isolated before you can make that call if it's going to have a solution or no solution. Now, sometimes we see absolute value on both sides of the equation. So in this case, I wanted to illustrate this with just a numeric example to kind of give you an idea of what's happening here. I know what the absolute value of 3 has to be. That has to be a positive number. So when we set up these equations, I'm going to have the original case, so just as is with dropping that absolute value bar. And then the other one is, again, what's inside of these absolute value bars could be negative. So it's giving me those 2 different options. So I'm still treating it the same. I'm dropping the absolute value, but I am keeping one side original, and then the other side is getting the opposite sign taken of it. So when I have something that looks a little bit more complicated, say, for example, this one, my first case is just going to be as is. All I'm doing is dropping the absolute value bars on both sides of the equation. My second case is, well, I'm going to keep one side exactly the same. So in this case, I'm just choosing to keep the left side the same. And then on the other side, I need to take the opposite of every single term in there. Now, I could have done the exact same thing. I could have left the right side alone and taken the opposite of the left side. I just choose to keep the left side the same and take the opposite of the right-hand side. So now you have these 2 pretty decent looking equations still to solve. So let's go ahead and take away 2x from both sides. And then we can add 4 to both sides. So x equals 5 is one of my solutions. And on this other side, let's distribute our negative sign. So that's going to make that negative 2x minus 1. So in this one, I'm going to add 2x to both sides. And I'm going to add 4 to both sides. And now divide by 5. So I'm going to get these 2 solutions here. We're going to get 5 and we're going to get 3/5. I could go ahead and plug both of those in, and I would see that I have the exact same answer on both sides. So this one, both of those solutions end up working. Now this one's a little bit interesting here. So again, absolute value on both sides. So case number 1 is, let's just go ahead and drop all of the absolute value. What we're doing is we're just taking what's inside of here and taking this one as is. And then case number 2, I'm going to take what I have on the left-hand side, and then I am taking the opposite of what I have on the right-hand side. And let's go through and let's solve both of these equations now. So for this left-hand side one, let's go ahead and add x to both sides. And then I'm going to go ahead and take away 4 and divide by 2. So x equals -4 is going to be one of my solutions. On the right-hand side one, let's distribute the -1. And now let's solve this equation. Now if you notice here, I actually have x's on both sides. So if I take away x from both sides, I'm left with the statement 4 equals 4. That is a true statement. Okay, 4 is always, always, always equal to 4. So what this tells me, because that's a true statement, is that this one, in fact, actually has infinite solutions. All real numbers would satisfy this equation. So for our solution set here, we could just put -infinity to infinity because it's all real numbers. I guess you could be really cool and put the R to represent the real numbers here, because anything you plug in, you're going to get the same exact thing on both sides. All right, so let's look at some inequalities here. So we're going to actually treat these exactly the same as we're treating the equations, but we are going to test which interval is going to work using interval testing. Interval testing is a pretty critical topic in calculus, so this is a really great time to introduce it. So looking at this problem, what I'm going to do is I'm just going to rewrite it as is, but I am going to put in an equal sign instead. And now this is something that I know how to solve. I need to isolate the absolute value. So the first thing I'm going to do is take away 2 from both sides, and then let's divide both sides by 3. And so here's my equation. 5 minus x, the absolute value of that, is going to be equal to 4. So what I'm going to do is I am actually going to solve this equation. I need a little bit more space here. Okay, so there's all my work there. Now, my second step would be, let's set up our 2 cases. So 5 minus x is going to equal 4. That'll be equation 1. And then 5 minus x equals -4. So I'm solving this just as is. So let's go ahead and take away 5 from both sides. And then we'll multiply or divide both sides by that -1. And on the other side, let's take away the 5, and then again multiply or divide both sides by that -1. So 1 and 9 are going to be these critical values here for me. So on my number line, I'm going to locate the points 1 and 9. Don't know why it's not working. So 1 and 9. Now, the idea behind interval testing, we talked about this a few lessons ago. Interval testing is I have actually 3 intervals now. I have stuff that's going to be numbers to the left of 1. I have numbers between 1 and 9, and then I have numbers that are greater than 9. So you can see on this number line, I have these 3 separate intervals. I am going to test a number that falls in each of these intervals. So for this one, I would say let's test x equals 0. It's always going to make my life easier if I find out where 0 is going to be and use that as one of my test points. So what I'm doing when I'm testing x equals 0 is I am going to plug it back into the original inequality, and I'm going to see if I get a true or a false statement. So if I plug in 0, I'm going to see is 3 times the absolute value of 5 minus 0 plus 2, is that, now I don't know, is that less than or equal to 14? So let's see, 5 minus 0 is 5, absolute value of 5 is 5. So this one is really 3 times 5 plus 2. Is that less than or equal to 14? And the answer here is no. It looks like I'm going to get 17. So what I'm going to do is I'm going to put a big X right there because that interval did not work. So let's move and let's test a number in between 1 and 9. You can pick anything you want. You can pick 1.1. You can pick 2, whatever you want. I might pick 5 if I'm just trying to be a little bit clever with my equation because I notice I'm going to get 0 there, and 0 is pretty easy to work with those values. So I'm going to choose x equals 5 for my test. But again, pick anything that's bigger than 1 but less than 9. So plug it back into that original inequality. So let's see, that's going to be 0 inside of there. So this whole thing goes away. So is 2 less than or equal to 14? The answer there is yes. So I'm going to put a little check mark right there because that interval worked. Now I have one more interval to test. So let's test something that's bigger than 9. So I'm going to be crazy and let's pick x equals 10. So that goes in for my x value. And let's see what we get. Inside the absolute value, that's going to be negative 5. And absolute value of negative 5 is 5. So I'm left with that statement again, 3 times 5 plus 2, is that less than or equal to 14? The answer here is no. So that interval did not work either. So what works is the numbers between 1 and 9. So what I do here is I'm going to go ahead and highlight that, just to make that real obvious for me. That's going to work. And then I need to decide about my endpoints. So for my endpoints here, this is where I go back and I look at what my inequality says. This inequality is a less than or equal to. So that tells me that those points are actually going to be included. So what is my solution set here? Well, my solution set is going to be 1 to 9 inclusive. That is going to be my interval of values that are going to work. So what happens if we have the exact same problem, but now we switch that from less than or equal to just less than? So I'm still going to get those same answers when I solve the equivalent equation. I'm going to get 1 and 9. And with my interval testing, that's going to tell me that the interval between 1 and 9 is going to work. However, now that this is just less than, these are now going to be open parentheses on here because it is not going to be inclusive on the 1 or 9. So now my solution set would be the interval 1 to 9, not inclusive. How does that change if it's greater than or equal to? Well, as you can imagine, we get the same values, 1 and 9, because the only thing that's changed here is the direction of the inequality sign. So now I'm looking for, well, what would make these bigger than 14? So notice back here with our testing, we got 17 for each of those values. So that tells me now with this that the left hand and the right hand intervals are now going to work, because I'm going to get something like when we test x equals 0 and test x equals 10, we're going to end up with, I think 17 is greater than or equal to 14 for both of those, and that definitely would be a true statement. So for this case, we're going to be looking at the outsides here of our number line. And then we can write this in our notation. So this would be from negative infinity to 1, inclusive, because it has the or equal to, and then union 9 to positive infinity. So that'd be our solution set there. And then likewise, if it was just greater than with the 1 and the 9, it would not include the 1 and the 9. So my solution set would look like that. Now, just a couple more cases here. Let's look at something like this. So the absolute value of 4x minus 5 plus 6 is less than or equal to 2. So we're still going to kind of run this the same way. And we are going to solve the equivalent absolute value equation. So first thing we're going to do is we're going to go ahead and take away the 6. And we're going to end up with the absolute value of 4x minus 5 is going to be equal to negative 4. Now, keep in mind, you already know the answer here. There is no solution to this equation. And if you even, wanted to look at it with the inequality in there, will the absolute value of something ever be less than or equal to a negative number? The answer to that is no, because absolute value, the smallest it could be is 0. The biggest it can be is going to be anything positive. So this will never happen. So this one would end up being a no solution problem. So just the empty set. And then last case, what if that's greater than or equal to 2? So let's take a look here. Again, I'm going to start by solving the equivalent equation. So I'm going to take away the 6 from both sides. And now this is going to be equal to negative 4. So this one, I want to kind of hesitate here because I have, again, it equals to a negative 4. But my original problem says that it's a greater than or equal to. So if I am going to be greater than or equal to negative 4, well, I think that's going to be everything. So let's sort of see what happens here. I actually kind of already know the answer right now when I see something like this, but let's just kind of work through it and see what happens. So take the original equation, just everything as is. That'll be our first case. And then our second case will be just let's take the opposite of it. So I'm going to solve these two equations. So let's start by adding 5 and then divide by 4. All right, I get 1/4. And then this other one, let's add the 5 and divide by 4. All right, so I don't get like the prettiest of values here, but that's fine. I don't really care because with interval testing, I'm going to pick pretty numbers to test. So I'm going to find 1/4 and I'm going to find 9/4. Now I still have 3 intervals to test, so let's test something that's smaller than 1/4. I would say let's test 0 because that's going to be the easiest. So go back to your original problem. Is the absolute value of 4 times 0 minus 5 plus 6, is that greater than or equal to 2? Well, let's see what's going to happen inside the absolute value. That's going to clean up to give me positive 5. And 5 plus 6 most definitely is greater than or equal to 2. So that interval works. Let's go in the middle. So between 1/4 and 9/4, I would say let's pick maybe 1 and let's see what we get. So is the absolute value of 4 times 1 minus 5 plus 6 greater than or equal to 2? Well, inside of here, that's going to be 4 minus 5, that's negative 1. Absolute value of that is positive 1. So is 1 plus 6 greater than or equal to 2? Absolutely. So that tells me this middle interval works as well. And then lastly, let's check something that's bigger than 9/4. Let's be crazy and let's pick x equals 3. So 4 times 3 minus 5, the absolute value of that, plus 6, is that greater than or equal to 2? Well, that's going to be 12 minus 5, that's 7. Absolute value of 7 is 7. And 7 plus 6 most definitely is greater than 2. So this tells me that all 3 of these intervals work. So what that tells me as far as my solution goes is we have from negative infinity to infinity. The real numbers, anything would end up solving this inequality. I know that, or I knew that based on this step right here, because if I'm still thinking about that with that inequality sign, will the absolute value of something always be greater than or equal to a negative number? Absolutely, because this side, the smallest this side could possibly be is 0, and 0 will always be bigger than a negative number. So that tells me this would have been an infinite solution case, or is an infinite solution case. Homework for today is to go through and do the R5, R8 absolute value equation and inequality homework